Welcome everyone and welcome to the AluVET vocational training and education for the aluminium sector. This training is co-funded by the Erasmus programme of the European Union. I am Jan Lukaszewski, the Technical Manager of the Aluminium Federation in the United Kingdom. The Introduction to Metals series of modules explains the simple theory of metals and of metallurgy to enable students in subsequent modules to understand aluminium, its alloys, how aluminium is heat treated, how it is rolled, extruded and/or welding. In this module, we shall be looking at how we hot and cold work metals, specifically aluminium. This project is funded with the support of the European Union. This publication reflects only the views of myself and the Aluminium Federation, and the Commission cannot be held responsible for the use which may be made of the information contained therein. This module will explain what hot and cold working is, how metals react to hot or cold working. We will explore cold working and its work hardening effects. Then we shall introduce and explain annealing and its effects. Finally, we shall see how aluminium behaves at elevated temperatures, that is hot working temperatures. Having completed this module, you will understand why and how to hot and cold work metals, the limitations and the advantages and effects of hot working. You will understand why and how to when cold work metals and the limitations and advantages of cold working. You will know how to strengthen metals through cold working. You will understand the mechanism of annealing and how to soften metals after cold working. You will be able to select the correct hot or cold working process and understand their effects on aluminium. To use hot or cold working and/or annealing to develop the required mechanical properties of aluminium, you'll be able to apply hot working to enable, you will also understand how hot working enables extrusion. You will understand and appreciate the effects of high temperature on the properties of aluminium. So let's understand a little bit about mechanical working of metals. As individual atoms are not bonded together to specific atoms, but held together by the charge of the electron cloud through the metallic bond, we can physically slip, that is, move the planes of metals, of atoms over each other. Simply, we can force the layers, the planes of metal atoms to slip easily past each other or one another, so we can reshape metals. Mechanical working. We term the ability to reshape metals ductility and the property malleability. The fact that atoms are still held together while we reshape the metals is the reason why metals are ductile and malleable, do not break or fail. So when we reshape a metal, we don't break the metallic bond. At elevated or hot temperatures, the atoms expand and the metallic bond is weakened, so we can slip or form metals at much lower forces at elevating temperatures than those forces required at room temperature. Either cold or hot, the metallic bond that holds the atoms together is a fast-moving cloud of electrons. It does not break nor fail, but just reshapes and continues to be shared by all the slipped atoms when we reshape metals. Thus, the metallic bond still holds the atoms together, and there is no loss of strength. The slipping of the planes of the atoms past each other enables us to change the shape of metals. Cloud of electrons holds the atoms together even when we reshape them. So let's start off by looking at cold working. Cold working is the physical deformation of the metal at ambient temperature, that is room temperature, by mechanically changing its shape. Bending or reducing its cross-sectional area, reshaping through drawing, rolling, stamping, even a simple bending operation are all forms of cold work when carried out at room temperature. Now, remember, we cannot destroy a metal. That is, we cannot destroy the volume of the metal. The volume of the metal will always change. So when we change the shape of a metal, we translate the metal into metal spread. So if we draw a wire, we reduce the diameter, as you can see in the picture, but increase the length. You can never destroy the volume of a metal. So the volume of the metal is the same, but when you work it, you change its shape. So perhaps when you roll a sheet, you flatten it, goes thinner, it goes longer. And in this example, you can see we're pulling a rod of aluminium through a die, changing it into the wire. So the reduction in diameter is changed into length growth. An important thing to realize, you never destroy a metal. The volume of a metal is constant. So let's see what cold working is. Well, cold working slips the planes of atoms past each other. The metallic bond does not break. The electron cloud just reconfigures. So slipping of the planes of atoms results in the grains being permanently compressed and elongated into the direction of work. So through cold work, we change the shape of the metal. In this case, we're rolling it. So we're reducing thickness into elongation. That is longitudinal length growth. The volume remaining the same. The change of shape slips the planes of atoms. They move past each other. Remember that the metallic bond is not broken. The cloud of electrons still holds everything together. So slipping of the planes of atoms results in the grains being permanently compressed and elongated in the direction of the work. Elongation is the effect of the planes of atoms being slipped. The greater the degree of shape change, that is work, the greater the deformation of the grains. So if you can see on the left-hand side, a nice annealed structure. On the right-hand side, heavily rolled structure with the planes of atoms slipped and the effect on the grains.